So let's look at something called color temperature in paint pigments. We've talked a little bit about this when we looked at the difference between a warm gray and a cool gray, but it's important to talk about it in the color range. So I have two uh, color models up here. On the left is the RYB color model, and on the right is the CMY color model. Um, the idea of color temperature means that a color has something called bias. Um, there are there really aren't pure pigments. It's almost impossible to create. Cyan, yellow, and magenta are probably the purest, and that's why I think they're really good to use when we start mixing primaries and secondaries. They're the ones that retain the least amount of color bias. So color bias means that a color favors uh, one side or the other. So if you look at yellow green, it's biased. It's really a green biased towards yellow. If we look at blue green, it's a blue biased towards a green, which makes it a cool blue. Um, the other thing to look at is that generally we consider that colors that move from yellow to red are warm, and colors that move from green to blue violet are cool. Um, what's interesting is that yellow green and red violet, or yellow green and violet on the CMY scale, are sometimes considered ambiguous in temperature. They could go either way depending on how you're using them in a color scheme. Let's look at this. So on the left we have a blue that is biased towards red, and so that would be considered a warm blue. And on the right we have a blue that's biased towards green and would be considered a cool blue. So you would use a warm red when you wanted to mix a violet. If you used a cool blue and you started mixing it with a cool red to make a violet, you would get something kind of muddy. Um, However, if you wanted to make green, you wouldn't want to use a warm blue. You'd want to use a cool blue, like the phthalo blue, which is biased towards green. Here we see the cool and warm primaries. If we were working in RYB, um, you can see that the only way to work in RYB is that you have to have uh, combinations of warm and cool primaries. So you'd have a warm blue, a cool blue, a warm yellow, a cool yellow, a warm red, and a cool red. What's nice about working in CMY is we don't have to do that. We can use our uh, yellow, cyan, and magenta, and they're relatively unbiased hues, and we can use them to mix. For example, we can use the magenta to make warm red, and we can also use it to make cool violet. So saturation scale of hue. So back to this color model here. This is RYB, but it'll work also in CMY, and your CMY color wheel has this scale. It's a little bit, it has a few more divisions, but when we mix complementary colors together, so colors that are opposite on the color wheel, as you mix them together, you're mixing them towards a neutral gray. So if we look at the scale underneath the color wheel here, if we start mixing, if we take the yellow and we start mixing 10% of violet in it, we get this muted yellow. When we mix about 40% of violet into it, we get a chromatic gray of yellow. And if we can mix them absolutely equally, we should get an absolute neutral gray. Now again, we know that the pigments are not as pure as that we can create um, on a digital scale in the computer. So it's going to bias towards warm or cool. So again, if we look at the violets, you can see that just on the right of the neutral gray is a chromatic gray of violet, because it's the violet with 40% of its complement. So you'll be doing this when you mix your when you do the color wheel and you're creating your various forms of saturation. So here we go. Here's a couple of examples of red to green and yellow to violet. Mixing complements together is the most efficient method of lowering saturation. It works very quickly and very efficiently. It will also be the least effective in actually changing the hue, because you can change the hue as you change saturation, but if we want to neutralize it and not really change the hue, mixing its complement is the best way to do it. So if we take violet and we add yellow to it, we haven't really changed its hue, we've just desaturated it. Tints, tones, and shades is something that we'll be working with. So these are adding white, gray, and black. So if you add white to a hue, you created a tint. If you add gray to a hue, it's called a tone. And if you add black to a hue, it's called a shade. And these are also ways of changing saturation and changing value, adding white, black, or gray. So here's sort of an idealized complementary scale from all the colors on all 12 colors on the color wheel. So there's 6 complementary relationships. So you can look at them all. This is again idealized. It was created in Illustrator. It's a fun exercise to go through and mix every single one in their complements. Again, ideally that all of them mixed together, you would end up with this 50% neutral hue right down the center here. This is practically impossible to get when we're mixing pigment hues because of their impurities. So one of the things we want to talk about is this idea of simultaneous contrast and saturation and value. So if we take a neutral gray and then we place it in complementary grounds, you're going to see that the grays are going to change both in value, but they are in saturation. Now, I can tell that this gray was not made from black and white. It was actually made by mixing the complements together of violet and yellow. And the way I can tell that, stare at this line right here. The longer you stare at it, you will see that this neutral gray becomes very biased towards violet on the left and more biased towards yellow on the right. It's not quite as strong as the illusion that we're seeing here. But you can also see that the value is apparently changing. The value should look darker here and lighter here. When we talk about the interaction of color, we can, if we do this carefully, we can shift hue, value, and saturation. So it's based on the context of its ground. So again, we have a red-orange here. It's a relatively complex color. It's been made up of red and yellow. But you can see, again, stare at the center line here, right where don't go back and forth, but just stare at the center line, and you can see that the one on the left really begins to shift towards its bias of magenta or red, and the one on the right really begins to shift towards its bias of orange and yellow. They are in fact exactly the same hue, but they're being affected by the ground or the context that they're in. After image is created through something called retinal fatigue. So stare at the yellow-green circle for about 30 seconds and then shift your focus over to the happy face and see if you can color the happy face with magenta. So what happens in retinal fatigue is that the after image is the complement of whatever color you're looking at. So this only works really well with pure hues. The other thing that's effective is that by surrounding the yellow-green with black, it forces us to see and isolates that yellow-green, and then it really makes the after image very striking. And this is the last slide. This is something called the Bezold effect, and it has to do with the interaction of color. I'll let you read this. I won't read the whole thing, but it's basically an optical illusion, and it was discovered that a color may appear different depending on its relationship to adjacent colors. This is a very specific problem that I've created in this painting. So this is not painted, this is color duct tape. So I haven't painted the tape. I've used just 4 colors in this. If you look at the orange in the bottom here, this appears to be a red orange, and this one appears to be a yellow orange. They're in fact exactly the same orange, but what's happening is, again, the violet, as it moves through the orange here, you're seeing this sort of optical mixing of the violet and the orange, and it creates this sort of red-orange appearance. And then you see, as it comes up, the violet goes underneath and becomes the ground, and now what we see is the yellow optically mixing with the orange, and it creates this effect of a yellow orange. So that's what's creating the apparent difference here. The blues are exactly the same. So that's it for this mini lesson, and I'll see you back in class.